Hi team, this is in response to the Google form and you guys wanting more feedback and talking over the slides. So I totally appreciate that. It was something that I thought about doing anyway. And right before I decided to do the screencast, Otis wanted to come and say hello. So for those of you that remember me talking about my little puppy, here he is. He's not so little anymore. Hey, right, I'm going to pop him down so we can get on. Nope, he doesn't want to. He's just going to sit here, so just ignore him. Rightio, so spatial variations is the differences over the area. So when we're looking at spatial variations of Muriwai, the Muriwai coastal environment, we're looking at how is it different from one end of Muriwai Beach to the other end. So for us, that's from Otakamiro Point, so the headland that sticks out into the ocean, through to Okiritoto Stream in the north, and then just south of Otakamiro Point, which is Mouldy Bay. So these are the areas that we're going to be looking at. So it's how something changes over time, no, over space, and what we are looking at here is the sand dunes and the sandy beach in particular. So let's go down to the next slide if I can. Coolio. So this is what we're going to be looking at today, which is exactly what I've just said already. So why there are no sand dunes at Mouldy Bay, why the dunes are different in the north of Muriwai Beach, so up near Okiritoto Stream, and why there are why they're different in the south, which is down by Otakamiro Point, and what's happening to the longshore drift, and how does that have an impact on the sandy beach? Because remember, when we looked at temporal variations, we also looked at the sandy beach. Right, so let's start. First things first, there are no sand dunes at Mouldy Bay, and this is due to the cliffs in the back of the beach, and longshore drift is really disrupted in this area because of the headland. So we don't have as much sediment being deposited on the beach, and because of the cliffs at the back of the beach, there's less erosion. So the beach itself doesn't have that huge intertidal zone that we're going to see up at Muriwai Beach. So the sediment can't dry as much, and when it doesn't dry, it can't be lifted into the air through our aeolian processes. If this doesn't happen, then we don't get the surface creep or the siltation or the movement of sediment to be moved to the back of the sand dunes, to the back of the beach where sand dunes would occur. What also happens is that the tidal range does go right up to the back of the beach and to where the cliffs are. So we've got constant swash and backwash happening, taking that sediment away. So therefore we can't have sand dunes being built, if that makes sense. Rightio, so let's have a look at Muriwai Beach itself. So in the southern end of Muriwai Beach, we have really steep sand dunes, and they within the first 500 meters of the beach. So if we have a look here, in this area here, we've got really tall, steep sand dunes, and that comes back to a couple of things which we're going to look at in the next couple of slides, but namely the planting of the grasses and also that longshore drift again. But let's just have a look at how sand dunes are made in the first place. So you guys would remember that we've got our longshore drift carrying the sediment up the beach in that northerly direction other than around the headland due to wave refraction. That sediment is then deposited onto the beach through swash, that swash action, that wave carrying the sediment up the beach and putting it there. A little bit of sediment gets carried back down through the backwash and continues in that northerly direction towards the Kaipara Harbour, the Kaipara Heads. Once the sediment is on the beach and it's in that intertidal zone, the sun and the climate processes are able to dry that sediment out. Once that sediment is dry, it's what we call friable. So it's dry, it can be picked up by the winds, and remember, we need the winds to be a minimum of 11 knots per hour to pick up our sediment, our titanomagnetite sediment. Once that's picked up, it moves in that siltation process or through surface creep to the foredunes at the back of the sandy beach. Once it gets there, it starts to build our sand dunes. Once it hits that zone of zero velocity, which is when it hits our grasses, our spinifex, our marram, and our pingao grasses. And those are the key things that make it quite different, the sand dunes at the northern end of the beach and the southern end of the beach. So at the northern end of the beach, which is up near the streams, up near Okiritoto stream, they're lovely sand dunes. They're nice, they're gentle, they're not very high, and they're very stable. Stable sand dunes are the key points there. So remember, down here at that southern end of the beach near the Otakamedo headland, we have steep, unstable sand dunes from 500 metres away from the headland through to Okiritoto stream, the last part of our study area. We've got wonderfully, gently sloping sand dunes which are lovely and stable. So how does this happen? First of all, the key interacting process that you're looking at here is the vegetation growth. So that's our biogeographical higher order processes with our pedological higher order processes, which is our sediment, and our climatological processes, which is our aeolian deposition and erosion. So our wind processes. So here we go. In the northern part of the beach, so at 500 metres north of the headland through to the stream, we get sand being carried through saltation and through suspension and surface creep, and it's deposited on the spinifex grass. So spinifex sand dune grasses are the main grasses up at that end of the beach. But what happens when the sand dune lands on the grass is that it starts to bury it. The difference is here is with spinifex, it doesn't put up more leaves to grow towards the light once it's been buried. It actually puts out more runners. And what happens is that once those runners come out, or tendrils is the actual correct term, it grows down towards the beach or up towards the back of the sand dunes. And so it makes a nice gently sloping sand dune because the tendrils and the runners are shaping the beach as it moves towards the sandy beach, the sand dunes, or towards the back dunes. At the other end, down by the headland, we've got our dunes that have been planted with marram grass. So if you think back to the temporal variations, they put in the marram grass there because through farming and through indigenous settlement, the vegetation had already been removed from the sand dunes. And what we know now is that actually we need sand dunes to balance the ecological balance, I suppose, for want of a better word. So what happens is these sand dunes were planted with exotic, so not native to New Zealand vegetation, so the marram grass, and that grows up. So once that is covered with the sediment, our tithomagnetite sand, instead of the tendrils growing down and out like what happens in the northern part, the leaves just go straight up and they create very tall and very steep sand dunes which are very unstable. And so what happens is as they grow taller and taller and taller, they start to get too heavy and they collapse on themselves, which escalates the erosional processes that happen at this part of the beach. But we also do have sand dunes there as a result of the planting. So this is why in the southern end of the beach, down near the headland, we have very steep, unstable dunes because of the grasses that have been planted there. And in the northern part of the beach, we have wonderfully stable dunes because it's got the native grasses there. I hope this is making sense to you guys. Right. The longshore drift. So this here actually impacts on the sandy beach. So this is the spatial variations of the sandy beach. So we know that through longshore drift and through swash and backwash, we get sediment either deposited or eroded from a beach. So that is part of the process there. what happens from 500 metres north of the headland all the way up to Okaritoto Stream. So in this area here, we get very uniform longshore drift. So we get what is typical for the west coast of New Zealand, where we get the longshore drift carrying the sediment up there, and then swash and backwash can happen in what we call a normal pattern. And so therefore we've got wide sandy beaches up near the stream. However, down here near the headland, we don't have uniform longshore drift happening because of something that is called wave refraction. Now, wave refraction comes in, and as the wave approaches the headland, the ground in this area here is actually shallower. And so what that does is that this starts to create a drag of the wave, and it causes it to bend and to shape towards the land. So up here we'll have uniform waves approaching the beach, and here we're not going to have uniform waves approaching the beach because of the bend of the wave refraction caused by the headland. So what happens in this area and in our Māori Bay area is we're more likely to see more backwash and less, we're going to see more erosion and less deposition of the sediment. Hope that makes sense. And this is the outcome. So for most of Muriwai Beach, for around the headland, we'll have about 100 metres wide of the sandy beach, but down for the rest of it, so that northerly direction, we have a nice wide sandy beach, which also helps the growth of those sand dunes. This diagram here should hopefully explain what I've just tried to say. I am running out of time on this screencast, so if you have any questions about any of this, please just put a comment underneath this on our Google Classroom page, and I will happily answer it. Please don't forget to fill out that Google form, and we'll find out when we can have some live face-to-face chat in this distance learning time. Alrighty team, look after yourselves, and I will see you again next week.